So let's follow up that video on mid-segments in a little more detail. Okay, let's refresh. The mid-segment of a triangle is a segment that, as we can see here, it's connecting two midpoints. So here we have BA and AC with midpoints M and N respectively. And we can see that they're midpoints because of these congruence markers here. And then we connect the two, that's a mid-segment. Okay, and we briefly discussed yesterday the mid-segment theorem, this idea that when you connect the midpoints, create that mid-segment, it will always run parallel to the opposite side or the third side. I kind of tend to call it the non-included side because we're just not really we use this side to get this midpoint, we use this side to get this midpoint. This is the non-included side that we're not using. Not only that, but we find strikingly it's also exactly 1/2 the measure. There is a coordinate proof of this, which I find quite interesting. I mean, I'm certainly a fan of proofs. You guys know that, right? So if we look here, you can see I've already sort of written it out. I want to walk through it. So I say, let's say we have 0, 0. And then we have 2q, 2r, 2p, 0. And the reason we use these variables is the idea behind a coordinate proof is this. You're going to show me 1,000 examples of why something works. But if there's one example of why it doesn't, then it can't be a true proven theorem because that means there's at least one counterexample. So we need to use something broad enough where I could put in any numbers I want for q, r, and p, and the truth will still follow through. So we can see here what I did is I found, well, what's the midpoint between 0, 0 and 2q, 2r? Let me go full screen so we can really get a look here. And that would be qr. So now you see why in this coordinate proof, the nice thing about a coordinate proof is I can sort of game the system where I know I want to find a midpoint. So instead of doing QR up here and winding up with Q over 2 and R over 2, I can just say, I'll make this 2Q, 2R. That way when I wind up cutting them in half to get the midpoint, it's just QR. Make my life a little bit easier. I'm going to do the same thing over here. And you can see, right, using the midpoint formula, that when creating the midpoint for E, I need to do x plus x, so 2q plus 2p, so I get q plus p is the x value right here. Now, if I'm calculating the length or distance, I've luckily set myself up where I don't need to use the distance formula. Again, kind of gaming the system, and then I'm using a horizontal line, so I don't have to use the distance formula. I can just count my way across and say, how far did I go from 0 to 2p? Well, a distance of 2p, of course. And then I say, well, how far am I going here from q to q plus p? Again, because I'm at the same height, r, I know it's a horizontal line, so I can sort of just say, well, what's the difference between the x values? That's my distance. So I take q plus p, and I subtract q, and what am I left with? The variable p, which is, that's how I get that 2-to-1 ratio. As always, guys, with these proofs, it's important to remember, I'm not going to test you on these things, but it's about deepening your understanding of why these things work. I believe it's fundamental in mathematics that you guys have an understanding of why and how, because that's what helps you remember it instead of me just throwing those theorems up there. So there's another explanation of the proof. And now we have these types of problems where we should be able to say, oh, well, if this is 26, that's half of it. That's 13. Well, if this is 5, that's half of this, so I can double it and get 10. And then catch yourself, okay? This is still a mid-segment problem, but asking you to recognize, oh, okay, I think the 6 and the x are part of this segment, which is being split by the mid-segment. So if this is 6, and so is 6. There's a couple questions here on the exit card that are great to look at, and there was a brief homework worksheet to go with this. It's a short video. It's a follow-up of yesterday's, but I hope that helps.